Graphics from IMSL is a library of flexible FORTRAN callable graphics subroutines. With these subroutines, you can create high-quality technical graphics from within your FORTRAN application programs. Over 70 FORTRAN subroutines range from automatic three-dimensional contour rendering to flexible low-level graphics primitives. Let's look at an example. This is a typical contour plot. With exponentGRAPHICS contour plotting routines, you can draw contour lines through equal values of a function, gridded data, or interpolated data. You have complete control over color, shading, and labeling. 200 colors can be selected by name, and over 16 million can be selected by specifying the percent of red, green, and blue. Fill areas can be hollow, solid, patterned, or hatched. You have independent control of line characteristics for hatches and outlines. You also have control of hatch line spacing and hatch line angles, along with a wide choice of fill pattern sizes and pattern arrays. You can see just how much control you have over plot elements. Now let me show you how easy it is to program plots using exponentGRAPHICS. Let's bring up the sample code. Because exponentGRAPHICS uses a FORTRAN command syntax, you can begin creating plots immediately. exponentGRAPHICS features mnemonic subroutine names, standard calling sequences, and uncomplicated argument structures. Here, take a look. The first thing you'll notice is how few lines of code it takes to produce sophisticated graphics. exponentGRAPHICS permits many graphs to be created automatically with just 2 calls to high-level subroutines. You call an application plot routine, and then an output routine to display the plot. These are commands used by our interpreter for graph customization. Here's the call to the contour routine. We provide a function, plotting limits, and specify various options such as fill types and labels. Here's the call to plot the contour. At this point, the plot will be sent directly to the specified output device. That's all there is to it. Now let's look at another frequently used plot, a 3D surface plot. As you can see from this real-time view, data rendering is fast. You may provide a function of 2 variables or gridded or interpolated data to create surface plots on rectangular domains. exponentGRAPHICS provides you with remarkable control over the appearance of a plot. For example, you can change the eye location to clarify or emphasize. Or you can move the apparent light source to highlight trends. With exponentGRAPHICS, you can also use different types of surface shading. Text, labels, and legends are important to give dimension and detail to the general shape of the plot. exponentGRAPHICS gives you a selection of 13 different text fonts. In addition, you can control character height, width, boldness, slant, color, spacing, and background. It's simple to change plot features such as these because of exponentGRAPHICS' structure. exponentGRAPHICS includes an interpreter that can reference standard or custom descriptions of plot features outside of your FORTRAN program. This means you can modify plots without recompiling and relinking. Now let's look at another frequently used graphic representation, the spline plot. In this case, we're looking at a B-spline plot, representing a least squares curve fit to a data set. exponentGRAPHICS offers significant flexibility with its spline plots. The spline plot can be combined with a scatter plot. You see not only the spline, but also the original data set. exponentGRAPHICS supports scatter plots with 20 different marker types. You have complete control over placement of all plot elements, legend, title, and tick marks. With exponentGRAPHICS, different plot types can be overlaid. You can also plot splines generated from our curve fitting support routines. Curve fitting is an important feature in exponentGRAPHICS. For this reason, several curve fitting routines are included, such as cubic splines, one-dimensional B-splines, and two-dimensional tensor product B-splines. While we've just shown you 3 of exponentGRAPHICS' more interesting plots, the system can generate a number of other important graphic representations. They include two-dimensional function plots, box plots, vector plots, histograms, bar charts, polar plots, pie charts, error bars, and confidence interval plots. In addition, standard graphics subroutines let programmers familiar with GKS, the graphical kernel system, access low-level graphics capabilities. I think you can quickly see how beneficial exponent graphics can be in communicating your data analysis. With exponent graphics, you can significantly reduce the number of calls in your program. Most plots can be created with only 2 calls to make your work easier. And exponent graphics permits modification of your plots without recompiling and relinking. Exponent graphics is fast and provides high-quality graphics. Consider the benefits: quicker program development because of simpler graphics programming, and time saved by using the familiar FORTRAN command syntax. Consider the value of a complete package with device drivers, interpreter, and curve fitting routines. With exponent graphics, there are no add-on modules to buy. Finally, you get the confidence of using a graphics product backed by IMSL's 20 years in numerical computing and technical product support rated as outstanding by our customers. Here's what some have said about exponent graphics. Exponent graphics. It's the tool to visualize your programming, to raise your graphics to a new power. For more information about exponent graphics, call us today.